Hello. Because physics has always been one of my interests, I ended up being very interested in quantum mechanics. And I remember when I was studying it or reading about it, I remember thinking, this reminds me, this principle, the kind of the essential phenomenon that quantum mechanics finds so odd, this essential phenomenon reminded me of something. And it wasn't until many years later that I realized what it reminded me of. And so this next video is a thought exercise that is an attempt to demonstrate what the essential nature of the phenomenon of quantum mechanics actually is. What in essence is the quantum mechanics phenomenon? So that's this next thought exercise is an exercise that addresses that question. I hope it's interesting. Thanks for watching.
Here we have a so-called optical illusion. It's called an optical illusion because, believe it or not, squares A and B are in fact the same shade of grey. And we can demonstrate this by doing this. But hang on. Does this really mean that the colour we see here is an illusion? After all, what is the true colour, if not the colour we are directly seeing? In other words, can we ever see colour as it is in itself? In reality, we never see colour on its own. We always see it within a specific wider context, such as light, dark, other colours, and, in this case, the conceptual context of being in the shadow of another object. So the only way we can ever see these two squares as being the same shade of grey is if we completely destroy the context in which they appear. Is it really fair to say, then, that this image shows the true colours and this one does not? Now, you might be tempted at this point to point out that the wavelengths of light emitted from both squares are identical. But now we get to the real beef of the matter. For now we are implying that behind the appearance of colour there is a concrete reality, and that this image represents that reality and this image does not. Now in this case we are setting up an observer who observes an appearance, but the appearance is considered not the true reality. The reality is what is inferred as existing behind the appearance. This is essentially the physicist's approach to colour and light, following the footsteps of Newton. Here the appearances are regarded not as reality, but only as images in consciousness, and that the true reality is the discrete mathematically determined entities independent of the appearance and the observer. Well, in what is almost a poetical irony, history has shown us that when we take this physicist's interpretation of the appearances to its logical end, we end up with being forced to the conclusion that light can both be a wave and a particle at the same time. Not only that, it changes between the two depending on how we choose to measure it. And so we come full circle. We began with this appearance. We were unsatisfied with it, changing depending on how we chose to present it. We then went down a long, laborious road of trying to discover the true reality behind the appearance, and lo and behold, that reality now also changes, depending on the context we choose to study it. So let's rewind to the beginning. Let's try another approach, such as Goethe's method of understanding nature. Goethe has an altogether different approach to studying nature. Instead of thinking of reality as existing behind the appearances, Goethe instead remains with them and seeks to understand the concept or law that belongs to the appearances themselves. In so doing, Goethe finds meaning in the appearances. Meaning is thus not excluded from nature in Goethe's method. He searches for the concept expressing itself in the appearance. This concept is the explanation of the appearance. Returning to our so-called optical illusion, as we've seen, colour expresses a conceptual element. The concept of the colour grey is that it is the midpoint between light and dark. The concept grey is that it is neither light nor dark, but rather pure shadow. It is no coincidence, then, that square B is represented in the shadow of the green cylinder, and that if we change the concept of this setup, the appearance must itself change, for we can't have the one without the other. Now, it's easy to demonstrate this with colour and abstract images such as this one. Not so easy to take this principle and apply it to the rest of nature. But we must. Returning to quantum mechanics, for example, it should be no surprise that when physicists play around with light and try to separate it away from its wider context, that they should end up with the anomalies they end up with. They haven't achieved any understanding about light at all, as they themselves proudly admit. As someone once said, if you claim to understand quantum mechanics, then you haven't understood quantum mechanics. This is because all they are really doing is just pushing light into ever more abstract parameters, where the slightest change in the setup gives a drastically different result. What they're effectively doing is similar to what we did when we did this, and mistakenly thought that somehow we have discovered the true colour. It's a delusion. So in conclusion, the real challenge here is to take the appearances seriously, to treat them as realities in their own right, and to also see that there is a conceptual element to their reality which we can also, if we manage to, participate in by virtue of our ability to think. Thanks for watching.